21B is all about calculating probabilities using the normal curve. So this gets more specific on how each of the percentages that are under the normal curve. So draw your curve. You're always going to start with putting in your mean straight up the middle. Then you're going to go one standard deviation away, match your inflection points. We're actually going to go 3 each direction. So notice this is 2 standard deviations away. This is 3 standard deviations away. And here we're going 1, 2, 3 standard deviations away this way. All right, so I talked about in A, how the middle, if you're 1 standard deviation away from the mean each way, that's 68%. This is giving you a little bit more specific values. So one thing I want you to understand is if this is the mean, then there's 50% to the left and 50% to the right. So the mean cuts everything in half. So if this is about 68%, that's why you're seeing each side gets that just split in half. Then when you are 2 standard deviations away, that's about 95%. 3 standard deviations is 99.7. So IB does give you a little bit better, more exact values, but this is your general idea here. And then we say within 4 standard deviations, and notice up here, that's what it's giving us. That we say 100% of your data, if it's normally distributed, 100% should fit within 4 standard deviations. All right, so for example 1, the 2 big things we need to know for normal distribution is your mean and your sample deviation. So the first thing you're always going to do is draw the curve. Put your mean down the middle. And I'm not real good about actually using the inflection points, but it's pretty close. Then what we're going to do is add 6 going to the right. So add 6 3 times. And then we're going to subtract 3 times to the left. So as I go to the left, I'm going to take my mean, 46 minus 6, 480 minus 6 again, 474 minus 6 again, 468. Then I'm going to add, going to the right. If I add 6, that's 492. Add it again, 498. Add it again, is 304. 504, sorry. All right. Now, what we're going to do is we want to estimate the percent. So everything under the curve is telling us about probability, and it's giving us the percent that lie in between. So if I want to know 480 to 486, that's going to be this part for letter A. So if you look up above, if you use your chart, it's just 34.13%. So that's why the chart's really helpful. And you just kind of you're not going to have to memorize these decimals, so that's a good thing. Most of the time we're going to be using the calculator, so that'll help, but you need to have a general understanding of each of these. All right, so for letter B, let me change my color. More than, you want to know the probability where the value is more than 492. So we just go from 492 this way. Now, the way I kind of think of it, we can add this plus this plus this and get our answer. I also know this is 50% and this is my 34. So I could take 50, that's all of that, plus 34 is 84.13 with our exact values. And then I can just take 1 minus that, to get the 15.87. To me, that's easier than adding all these little weird decimals up, but we can do that too. But basically, and a lot of times what they'll have you do is shade the correct amount. So make sure, I would actually draw a picture for each of these and demonstrate using shading what you're referring to. All right, so looking at the chest measurements of 18-year-old rugby players. So as soon as it says normally distributed, draw your curve. Your mean is 95, standard deviation is 8. You're going to be checked, they're going to check to see that you always put your mean in the middle. And then we go 1, 2, 3 to the right, 1, 2, 3 to the left. Add 8 going to the right. And subtract it going to the left. All right. Now notice it says from a group of 200 players, how many would you expect? So that's going to be our expected value to be between 87 and 111. So 87 and 111, we can calculate the probability by looking here. So if I add, I know this is my 34.13, this is 34.13, and then we also have the 13.59. So if we add all of those up, the probability that it's in between 87 and 111, adding all those probabilities up, it's going to be 81.85%. But the question is asking for more. We need to figure out how many we would expect out of 200. Well, we just take our number. So our expected value that we would expect to see out of 200, we just take our total times our percent, and we get approximately 164 players. That's for letter A. Now, K will be one of your numbers down below. Find the value of K such that, so we want to find the probability that X equals K that gives us 16%. So that, below K, less than or equal to K. So we're going to add all these up until we're approximately 16%. Well, this is our 13.59, this is our 2, this is 0.15. So this would be 15%, 16% here. So that means my K value has to be 87. So we're trying to just make the numbers work until we find that correct value. All right. This one's all about technology, so if you want to get your calculators out. So anytime we're talking about distribution, remember to take the second vars, the distribution button is what we're going to be looking for. So we're just going to straight up plug this stuff in. It tells us the mean is 40. Standard deviation is 10. So this is kind of in the middle here. So when you notice, go ahead and, and the other thing, when we're using our normal distribution, we're only going to use CDF because normally distributed values have to be cumulative. It's never going to be exact. So Notice the two at the top are right away normal. Number 2 is your normal CDF. We will always use CDF. Notice when you first turn it on, it says the lower value is -1 E99. That's your -10 to the 99th power. And what that does, that makes this a really, really tiny value. So we just use that if we want to use the smallest value possible. All right, so just kind of maybe jot that down. If you want the upper, you don't have an upper value. So notice here we have a lower value and an upper value. Here we don't. So if you need a lower, this is what you would write for your lower. And your upper is 1 E99. So you might want to jot that down. Usually I'll just turn off my calculator if I can't remember how to put it in, and then I remember. It just normally goes back to that. All right, so notice when you push normal CDF, lower, you just put your lower bound, 37. Then you put your upper bound, 48. Type in your mean. Type in your standard deviation. Paste, hit enter. And the probability, if X is normally distributed, that it's in between is 0.406. So it's just straight up plug it in your calculator. All right, for letter, we'll use this for all of our ABCs. For letter B, we want it to be greater than. Oh, notice it said it wants us to illustrate your answers. Big thing here, we want to put our mean at 40. 37, I just need to put below my mean. 48 is above my mean. Label those and shade in between. And that there's times you're going to be graded on that. So the big thing you need is your mean and the values here. Just include that. It doesn't have to be real specific. It's just a basic sketch. All right, so then for this one, if my mean is at 40, what's the probability it's greater than 45? Well, 45 is to the right of the mean, so it's just right here. So then when you go into your normal distribution, normal CDF, this is your lower value, then your upper, do 1, and then do second comma. That's the EE 99. That's what we do for upper. Then we just keep the mean, standard deviation, all the same. And when we round it, the probability that X is greater than 45, make sure you're looking, should be 309. At 85, they're always going to have, I always see 5s at that fourth number, so make sure you round up to 9. All right, then for letter C, here's our mean. So 26 is to the left of the mean, and I want it less than 26. So we're going to calculate the probability that X is less than 26. So go back to your normal distribution, CDF. This time our lower, so put -1, second comma, EE 99. Then we're going to put 26 as our upper value. And just go down and paste, enter. And 0.081. Make sure you round up for that one. All right, so that's how you use your calculator to calculate normal distributed probability. All right, the last one is probably more like you're going to see on the IB test because it's kind of a combination of things. So the times taken for students to complete a puzzle are normally distributed. So go ahead and draw your curve. The mean, 28.3. Standard deviation, 3.6. Calculate the probability that it took at least 30. All right, so I'm going to just put in my mean, 28.3. At least 30, here's my 30. So at least 30 is 30 or more. So this is what we're going to calculate. So first of all, letter A is the probability that X is greater than 30. So let's go to our normal distribution. Normal CDF. This is our lower 30. And that's what the picture is really helpful to see that when you sketch it out. Remember then for the upper, that's +1, EE, second comma, 99. Now we have to change our mean to 28.3, standard deviation to 3.6, paste. And this particular probability is 0.318. So that's very consistent with what we've been doing, and that's all we need for letter A. But letter B, notice how they change it up. Out of 10 students, we're looking for the probability that 5 or fewer of them took at least 30. So as soon as it says out of 10, immediately I see this as a binomial probability. Okay, and as soon as you write down binomial, you're going to get 1 point just for recognizing that and writing it down. All right, so the whole point that they had us do letter A, this is the probability for this particular problem because we're looking that 5 or fewer out of 10 took at least 30. So we're going to incorporate this into the binomial. All right, so we're going to look for the probability that X is less than or equal to 5 or fewer. And we're going to use our binomial distribution where our probability is 0.318. The number of trials is 10. So go back to your distribution, hit your up arrow though to go to your binomial. Because this is less than or equal to 5, we're going to use binomial CDF. The number of trials is 10. Our probability value 0.318. Our X value is 5. Go ahead and paste it. And this probability 0.938. And that's our final answer.